Okay, so now you had to use this condition to just solve this question, right? I hope it will make sense now. Okay. So now we have center of gravity. Can you explain what is center of gravity?
सर एक पॉइंट ऑफ द बॉडी जहाँ और पूरी फोर्स लग रही है.
Okay. Anyone else? Good. Anyone else want to explain center of gravity? Yes.
Sir, we can say that it's the point where all the gravity is like concentrated.
Good. Good. So from concentrated point of view, what other phenomena comes into your head?
मास.
Good. Good. So yeah, you know that K weight is equals to mg, right? Okay. So if I'm talking about center of gravity, right? So it should also be linked to center of mass, right? Okay, it should have a connection of with center of mass, right? Okay. So now let's define the definitions of both of them, right? So let's define center of gravity first, and then let's define center of mass, right? And let's see okay, how are they different and how are they same, right? So what is center of gravity? As Ryan said, it is a point. It is the point at which the weight of an object appears to act. Does that make sense? Right? So if I have, let's say, if I have a point mass like this, so iska center would be a point where you basically be drawing your center of gravity, right? So you would have a vector of weight from the center of gravity, center of circle from here, and you will show it by W. Okay, so this is your center of gravity. So it is a point at which the weight of an object appears to act, right? So you are assuming that we have masses also over here also, over here also, but we usually for simplicity we take K it is the for geometric objects, let's say for circles, for squares, for rectangles, your geometric center is the point of center of gravity. Does that make sense? Okay. So let's find some center of gravity for regular objects, right? For regular objects, for regular shapes. Okay. Let's start with a rectangle. So where is the center of gravity?
सर इन द मिडल.
Right. So how do you find it out experimentally?
सर वो एक लैम्डा होता है ना जिसमें लाइक एक पिन होती है और उस पे थ्रेड लगा हुआ होता है.
Like
और
regular objects. For regular,
ओके.
you just draw diagonal lines, and when the diagonal lines are basically intersecting, that is your center of gravity, right? For regular objects, this is your center of gravity. Does that make sense? Does it make sense? Give me a thumbs up if it makes sense. For rectangles. Okay, good. So let me just now do for different shapes. ताकि it makes sense to you guys. कि how do you find it, right? It comes in your MCQs theory. So let me just do it once. So now let's do it for a square, right? Right. Again, you will draw two diagonal lines, right, touching the corners, and the point where they are touching is basically your center of gravity. Okay. So now let's draw it for a circle. एक मिनट रुके. Okay. So again, इसमें you just need to draw two diameter lines, right? This is one diameter, this is another diameter, and this is the point where you basically will have your center of gravity. Okay. So similarly, you can find it for triangles also. ठीक है जी? For triangles. Okay. So again, you draw a line of symmetries over here. And so this is your center of gravity. Right? Does that make sense? How do you find center of gravities of regular objects? Okay. Quickly give me a thumbs up. Okay, I can just take your feedbacks. Okay. Maeve, is it not clear?
No, I understood it.
Which part is not clear?
No, I understood it.
Okay, you understood it. Okay. Good. So now if I talk about irregular objects, if I talk about irregular objects, so what have I drawn over here? Irregular objects. So have you done this experiment? Do you recall this experiment of Lamina?
Yes.
So for irregular objects, if you want to find center of gravity, okay, so we will just do it with the experiment of center of mass, right? So let imagine if you have irregular object like this, right? How would you find its center of gravity and center of mass? Okay, so how would you find center of gravity and center of mass? Right. So before that, I'm going to just give you a definition of center of mass. Okay. So let's discuss it out. What is center of mass? So what is center of mass? Can you explain? What will be center of mass of an object? Yes, anyone. Anyone daring enough to take the lead and answer. Yes, Vardha.
सर एक पॉइंट पे जहाँ पूरी मास कंसंट्रेट होती है या पूरी मास लाइक ज्यादा होती है.
So is it same as center of gravity?
नहीं, क्योंकि वो सेंटर ऑफ ग्रेविटी एक पॉइंट पे अफेक्ट होती है.
Okay, ठीक है. Anyone else?
Sir,
Yes.
the center of gravity is a pull, and the center of mass is like mass.
Perfect. Perfect. Okay, जी. Good. ठीक है जी. That's good. So let's write it out formally. So it is a point. Right? It is a point where all of the mass of an object is concentrated. Right. So just imagine basically be sure to use correct terminologies in your answer. Right. क्या लिख दिया मैंने? Is concentrated, right? This is very important. Where all of the mass of an object is concentrated, right? So it's pretty similar to center of gravity, but it is basically saying okay, where all of the mass of an object is concentrated. Like imagine okay, if we just talk about regular objects, right? Let me just draw regular shapes. Okay, how do we find center of mass for regular shapes? It's pretty similar to center of gravity. Right? So let me just draw shapes. Let's imagine if we have a rectangle. Okay. Okay, into shape tuning of it. Let me just do it again. If we just talk about this. Good. Okay. So if I make a rectangle over here, you can see here, if I want to find center of mass, again I will draw diagonal lines. Right? So now again, this is also the center of mass, right? I will not draw any vector. This is also a point where the entire mass of an object is concentrated, right? So imagine the formula, right? Weight equals to mg, right? So we can just see कि mass and weight are tightly proportional to each other, right? So you can see कि यहाँ पे weight भी add कर रहा है and यहाँ पे सारी mass is also concentrated over here, right? So for simplicity, physicists assume a single point of a body where the entire mass is concentrated, just to make calculations simpler. Otherwise, you would have weight vector over here also, some weight over here also, some weight over here also. This would mess up your calculations and it makes calculation pretty complex. So for simplicity, we only take center of mass and center of gravity points to assume that the entire weight of an object of a regular shape is acting at the same point, right? So for regular shapes, center of mass and weight हमारे पास same point पे होता है. Does that make sense? So if I just draw a square also, okay. So let's say this is a square and this is length by length. Again, if I draw diagonal lines, right? So this is also the point of center of mass, right? Okay. So now let me just draw for the last example a circle. Okay, you can draw diameter lines over here. Okay, I need to diameter lines. Okay, this is not good. Let me just draw it correctly. I need to diameter lines like this. Okay, so this will be the basic center of mass over here. Okay, this my drawing is not good. This is the center of mass of regular objects, right? So now we are talking about irregular shapes, right? So now let's see how do we find center of mass and center of gravity for irregular shapes. The meeting is about to end. Kindly rejoin everyone. Okay, let's not waste time. So now, is it clear till now? How do we find center of mass and center of gravity of regular objects? If it is clear, give me a thumbs up. Quickly give me a thumbs up. Ryan, not clear? Okay, so now let's quickly let's see what is the content which was written in the slide. Taki we can just progress forward. So center of gravity is defined as follows, which we have done in your last class. I told you guys to balance your scales, right, or a pen. So you basically place your finger in such a way that it was balanced, right? So for a regular scale, the center value would be 50, right? So if you put a support over here, your scale will balance out. Similarly, just imagine your finger over here, right? You were using your finger as a lever, right, as a pivot, right, which basically made you find the center point, right, the center of mass. Okay. So your weight of a regular scale is basically at the center. You also found out, okay, if you recall your experiments, you have pictures of those, right? You can open them and you can see, okay, it was approximately the center of the scale. Okay. So when you point, let's imagine if your finger is over here, the scale would be basically toppling over here, right, in clockwise direction. Okay. So what is written over here? An object behaves as if its whole mass were concentrated at one point, right? That is called the center of gravity, right? The object's weight can be considered at this particular point. So for your easiness, for your convenience, we assume a single point at which the entire weight of a body is acting, right? And for center of gravity of a uniform scale, uniform ruler means कि it has uniform mass, right? So यहाँ पे जो mass है, let's say the mass one at the left and mass two at the right is uniformly distributed, right? ऐसा नहीं है कि यहाँ से scale thick है, यहाँ से scale basically is thinner over here, which basically distributes the mass unevenly. We're assuming that the scale has uniform mass distribution, right? So then we can simply say that the center of the scale is the point where it can be balanced, right? I hope it makes sense, right? If you have question, please raise your hand. And then we have this defined center of gravity, and we have found the center of gravity of regular shapes. We'll find that how do we find for irregular shapes in a while. And we had defined center of mass. Center of mass is linked with the center of with weight also. Therefore, for regular shapes, we can say कि जहाँ पे center of mass होगा, वहीं पे center of weight भी होगा हमारे पास, right? Center of gravity. Okay, so now let's start with the non-uniform shapes, right? Let's start with the non-uniform shapes. ठीक है जी, इसके अंदर we'll find both. We'll find center of gravity. I find also center of mass. Okay. So this experiment is called the lamina experiment, right? The lamina experiment. Okay, so in this, what do we have? We have the following setup. So we have a retort stand, right? We have a retort stand, okay, and then we have a thread, right? And we have a ball bearing, right, which is a metal ball bearing. Let me just make it with red, right? So we have a thread and we have a ball bearing, just to basically keep the thread straight, right? And then we also have the laminate. We have the laminate. So let me just write down the steps for the experiment. Then we will explain it using diagrams, right? So what are the steps of this to perform the experiment? So imagine you have your lamina like this, right? Imagine you take 2 points, 3 points, right? A, B, C. What is the step number one? It is as follows. Okay. You make holes. This is your laminate. The lamina is called a sheet, right? It's just a sheet, irregular shaped sheet. So you want to make holes at the edges of your lamina, right? Such that they are not at the boundaries, right? They are not at the boundaries. Right? Imagine if you make a hole here, okay? So this, let's say if you hang your lamina on your retort stand, so this would break out. This would basically break out your lamina, right? So you want to make sure okay, they are at the at the edges, but not close to the boundary, such that your lamina does not tear off, right? Okay, so you want to make sure this thing okay, it is not at the boundary. Okay, and the second step is you will do what? You will basically hang this up. You will hang this through the through on your retort stand, right? Like this. This is your retort stand, right? And this is your this will be your thread, right? Which is basically over here, right? Imagine this gate is straight, right? So you will basically do this. You will hang the lamina, and in front of your lamina, you will hang the string with the ball bearing, right? So this would be straight, right? I'm just making it inclined so that just to make you watch कि आपकी line कैसे बनेगी, right? So then you will do what? You will hang the lamina. You will hang the lamina on the retort stand. On the retort stand and place the string. Place the thread with ball bearing at the top of lamina, at the front of lamina, right? Right. So you will have this setup, okay, which you can see over here right now. So you will then do what? You will take a pencil, okay. You will take a pencil and mark a line over here, right? You mark a line over here. Okay, this is the line which is basically when it gets settled out, okay, when your lamina is now rotating around the pivot, and when your thread is also stationary, when it is in equilibrium, you will take a pencil and you will draw the line on the thread with the thread, right, on the lamina. So your lamina would look like this, okay. Your lamina is this. Let me just replicate the lamina, right? So this is your point A, this is your point B, and this is your point C, right? You have hanged the lamina through this hole, and you have got this particular line with a pencil, right, on your lamina, right? And then you will do what? The third step is to basically repeat step 2 for hole B and hole C, right? So you will obtain 3 lines on the lamina, and you will see such lines, right? Okay. And then the last step is that the intersecting point, the intersecting point of these 3 lines will be called what? Center of gravity over here, right? Which is also center of mass, right? So if I just write down the fourth step, the intersecting point of all the three lines is called the center of mass as well as center of gravity. Does the experiment make sense? Right? So you figure out here roughly around here, all of the mass of the lamina is concentrated. Similarly, at the center of mass, you would have a vector which is basically showing your gravity vector over here. Because the weight is also acting at this particular point, center of gravity. Does that make sense? Let me add the link over here. Okay. So I have added this link over here. So yeah. So this there are similar steps, but I use a plumb, not a plumb, and I use a string in a ball bearing just to make it simpler for you guys. So you have the same steps over here that make hole at the edges of your lamina. Okay. And you just hang the lamina from your one of the load. And in front of your lamina, you just place your plumb line, and when it is stationary, you mark a line it with a pencil. And then you repeat this step with your whole B and C. So the lines where you basically see okay, the three lines are intersecting, that is your center of gravity, right? And for a human, just the last point to cover, and then we'll continue in the next class, inshallah. The last point is, can you explain, let's say if I have a human being, right? What would be the center of gravity of a normal person? Imagine her. Let's say imagine this is Hamza. Where is the center of gravity of Hamza, of a normal human being? Yes.
Sir, the legs.
Okay. Legs. Anyone else?
Sir, maybe the stomach.
You are close. Close. What point of stomach?
Like the upper part.
It basically use the it is a navel point of a human body, right? Where you have the center of mass, and at that point you also have center of gravity, right? So at this point, okay, around the navel point, you have your center of gravity, right? So which is basically this side. Okay. So now let me just tell you a definition of center of gravity, which we have seen in also. Center of gravity is the point through which all of an object's weight can be considered to act, which we have seen. It is a point where the entire weight of an object of a body appears to act, right? It is same as that. So this experiment is just I want you guys to do the experiment in your homes, okay? After the class, just stick to one of your wall with your foot perpendicularly straight and your hand basically like this, and try to raise your right or basically left or right leg in this direction, right? You will be basically be unstable and you will fall down, right? Because imagine this, until and unless this is the region, right? This is the area of your foot, right? If your arrow W is within this boundary, your body is stable, right? You won't topple down. If you try to stand on your one leg, okay, let's say if you are trying to stand on your one leg like this, right? So your weight component is pretty close to your boundary, right? It is over here. So that is why you start to topple down and you basically are about to fall down. Let's say if you're toppling, if you're trying to stand on your one feet and your feet is way too basically slanted, okay, your body is like this. And if your component of your weight, let me just draw it more tilted. Let's say Hamza is doing an experiment for the law of physics, and he basically does this, right? So now your weight is basically acting like this, right? So at this point, Hamza would whoa, Hamza would fell down, right? So this is basically explaining the idea of stability. So now from this steps, step number one, step number two, step number three, what do you guys get? What phenomena are we discussing over here? We have seen center of gravity, right? We have seen experiments to find center of gravity of regular and irregular shapes. जो हमने अभी डिस्कस किया है steps 1, 2 and 3, basically trying to reach a point where you topple down or fell down. So what is this phenomenon called?
Being stable, like
Stability. That's good. So yeah, stability, as we did the example over here, right? Hamza was playing with himself, right? He's trying to basically stand on one of his leg. Okay, let's say he was trying to show off to a little cousin, right? Okay, yeah, look at me, I can stand on one feet without falling. And he basically failed, right? So at the third step, he fell down because I guess he might have not studied this chapter with me before, right? He is now studying it, right? Now he can basically follow all the steps, right?